Hey kids, we're finally to the point where we get to talk about moles, and we will talk about mole extra credit tomorrow in our own little mole day celebration. Today, though, we're going to start with the basics. Okay? How many donuts are in a dozen? Go ahead. Shout it out. Hopefully you all said 12. If you didn't, we may have some problems. How many donuts, therefore, would be in 5 dozen? What do you have to do? Well, you multiply 5 times 12, which happens to be 60. How many donuts in 9.257 dozen? You're going to have a calculator for this. 12 times, I guess I could do the calculator on the board so you can see me. 12 times 9.257 is 111.084. A couple weeks ago, Donut Shop in Wichita came to Kansas City, to Olathe, and brought donuts. And the donut shop's name is Hertz Donut. Get it? Hertz Donut. And they brought their donuts in an ambulance because it hurts, don't it? So they brought, I want to say, 600 dozen donuts. How many donuts is that? Well, up here we took 1 dozen times 12 per one, and we got 12. Here, we knew we had 5 dozen, and we know there are 12 donuts in 1 dozen. Here, we took 9.257, and we multiplied by 12 over 1. So what are we going to do to figure out 16 dozen? How many donuts? Well, I know there are 600 dozen, and I know that there are 12 donuts in 1 dozen. So I'm going to take 600 times 12. $7,200 donuts. What if I asked you how many dozen are in 10,000 donuts? Well, up here we were using a ratio, 12 donuts in 1 dozen, so we multiplied. Now we're going the other direction. 10,000 donuts, we know that there are 12 donuts per 1 dozen. So, what do we have to do? Well, we have to divide. I was going to do it on the calculator again. 10,000 divided by 12. Try it again. 10,000 divided by 1, 2 gives us 833 dozen. So if Hertz Donuts would have wanted to bring 10,000 donuts to Olathe, they would have had to bring 833 dozen. So why are we talking about this? Well, we cannot count an atom. Atoms are very, very small. So scientists have created a way to represent this. All right, and that value is the mole. Mole means little pile or heap. All right, so a pile of atoms is a mole. They came up with the number 6.022 times 10 to the 23rd, and that is Avogadro's number, named after Amadeo Avogadro, not because he invented it, but because he did other things that were important, like he came up with, worked with gases and ratios of gases and determined the different ratios of gases at the same temperature and volume will always have the same number of particles. So we have to use this special number to talk about atoms. Now I have a video that I want to show, and I think that you will enjoy the video much more than me talking. So I'm going to get that queued up for you here.
A mole is an animal that burrows in the ground, or a spot on your chin that you gotta shave around. But there's another kind of mole of interest to me. That's the kind of mole they use in chemistry. A mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Now say you had a mole of pennies to distribute round the world. Give to each of the 5 billion grown-ups, boys and girls. There wouldn't be a single soul down and out of luck, 'cause everybody in the world would get $1 trillion. Or say you had a mole of paper and stacked it toward the sky. Paper's awful thin, but that pile would get so high it'd reach up into outer space. In fact, I think you'd find it'd go up to the moon and back 80 billion times. And a mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Now suppose a mole of marshmallows fell upon the planet. Over each square inch of land and sea, you think that you could stand it? That layer would be 12 miles high and of course block out the sun. We're talking close to 5 million trillion tons. Well, maybe we could save ourselves if we all started eating 1 marshmallow each second. Not 2, 'cause that'd be cheating. With 5 billion people munching, how long you think it'd take? 40 million years, and that's without a bathroom break. And a mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. But say you had a mole of atoms, would the pile be immense? Should I say the answer now or leave you in suspense? Well, atoms are so very, very small, you understand. You could hold a mole of atoms in the palm of your hand. So shake a little sugar in the middle of your palm. Now you don't want to spill it, so try and stay calm. You hardly can imagine and barely realize there are more atoms in that sugar than stars up in the sky. And a mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend.
Okay, I know that's a very silly video, and you can find several of them. That song is a song by Michael Offit, and somebody did that for a project, some student, and put it in video graphics, which apparently are from a video game, I have been told. So that's where that comes from. But it gives you the idea. A mole is a unit, just like a dozen is a unit. And so we can use a mole to calculate the number of particles. Okay? Avogadro's number is 6.0221415 times 10 to the 23rd. Now, guess what we need to do? We need to understand how to use our calculator and put in scientific notation. So we're going to take a brief pause for that. Everyone needs to have a calculator out. If you don't have a calculator, you can borrow one of mine. Phones are not going to work. You need to have a calculator. Okay? So, get your calculators out. Okay, this is the kind of calculator I have. And the keys that you are going to need to use in order to be able to do this, you're going to be able to, you need to, the second key, and this key down here that says x to the -1, but the second function is EE. What that means is that button can do two things. If you hit the second button, it will do the little part printed on top. Okay? Now, even though this is going to make you dizzy, I'm going to show you how to do this with my camera. Okay, I don't know if that's going to focus or not. So let's put in Avogadro's number. The way you do this for scientific notation, 6 point, oh, I guess I have to turn it on first, don't I? On. Okay, ready? 6.02. Now we're going to put the scientific notation in. All that means is you're multiplying it by that huge number. We're going to multiply it. I'm going to hit second, EE, and now I'm going to put in 23. Okay? That means 6.02 with 23 zeros, well, 21 plus the O and the 2 past the decimal. Okay? That's all that means. If I want to multiply that by 6, I hit 6, and I hit equal, and I get 3.6. Let's move this up so there's nothing behind it. 3.612 times 10. Can you see the 24 in there real faint? Times 10 to the 24th. That is how we use scientific notation. So for this worksheet today, you're going to need to be able to use the calculator and calculate scientific notation. All right? All right. Hopefully you've all learned that in math. I realize it's not always the case. I know y'all want to see the donut hat. Now you know why I'm wearing the donut hat, because we talked about donuts. Now you're all hungry. Okay, so let's pull up the Alright, before we go on, I would like to help you create a tool called a mole map that you will use as you work problems. And this is something we will use the rest of the year. So if the substitute could go ahead and pass out the orangey colored sheet that has this diagram on it, and go ahead and pause while you do that. Alright, what I'm going to have you guys do, first of all, in the middle, and of course, as usual, there we go. Having technical difficulties, thanks Jeff. We're going to write moles in the middle of our mole. And down in your lower left-hand corner, we want to write particles. And I'm having a little technical difficulty. Sorry about that. You're going to write particles. Okay? And I'm going to switch to another one that has the things drawn in that I need, because my machine obviously does not want to work. Surprise, surprise. So, here we go. We've got particles written in the lower left-hand box. Now, draw an arrow from the mole to the box that says particles. And write next to that times 6.02 times 10 to the 23rd. Okay? And then draw an arrow going back that says divide by 6.02 times 10 to the 23rd. Why are we doing this? Well, if we have 12 dozen donuts. And we want to know how many donuts that is. We multiply to go from dozen to donuts. We multiply. There's 1 dozen, and there would be 12 donuts in 1 dozen. Well, our mole map, if we want to go from moles to particles, our mole map, we're going to multiply, because there are 6.02 times 10 to the 23rd particles in 1 mole, just like there's 1 dozen donuts, or 12 donuts in 1 dozen. Okay? All right, so now we'll go on and do the worksheet. Worksheet, and all right, so look at this worksheet, Avogadro's number worksheet. What you're going to do, first of all, define mole in your own words. Well, you can do that. You can figure that out. Number 2, though, now we're going to start doing some calculations. Okay? How many moles are present in 7.5 times 10 to the 24th formula units of magnesium chloride? That should be MgCl2. By the way, that is a horrible typo that I'm going to need to fix. Okay? 7.5 times 10 to the 24th formula units. Of formula units, we've been talking about covalent and ionic compounds. Covalent compounds are molecules. Ionic compounds are crystal lattices. And the simplest form of that, the empirical formula of that, is also called a formula unit. So that's all that means. Since the magnesium chloride is an ionic compound, that's what we're dealing with. You're going to take 7.5 times 10 to the 24th, and you know how you abbreviate formula units? It's kind of fun. FU. Yeah, I know I'm juvenile. All right. So 7.5 times 10 to the 24th formula units. How many molecules are in one, or formula units would be in 1 mole? Well, we know that 1 mole contains 6.02 times 10 to the 23rd formula units. Take my hat off. All right. What's that going to look like when I punch it into the calculator? I'm going to take 7.5 second EE 24 divided by 6.02 second EE 23. 12.45847 blah, 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 blah. We'll do 12.46 moles. Okay? Let's try the next one. 2.45. Well, no, let's not do the next one. Let's pop down here to number 5. 6.54 moles of sodium chloride, and we want to convert that to formula units. All right, well, we know that ratio, that 1 mole is 6.02. This time we've been given moles, and we're solving for formula units. So we're going to put our mole on the bottom of our ratio, and we're going to multiply that times 6.02 times 10 to the 23rd formula units. Okay, moles will cancel, and if we do it on the calculator, 6.54 second, oh, we don't need to do second, start over again, 6.54, and we're going to multiply that by times 6.02 second EE 23, and we get 3.94 times 10 to the 20, okay, get out of my way, 24 formula units. Okay, I want you to go ahead and work at the rest of this worksheet for tomorrow, and we will discuss it then. Thank you very much.